Solidscape is an American-based company which has been operating successfully for many years now. This growing company produces rapid prototyping machines which are sold throughout the world. Solidscape have released their new R66 and T76 wax printers. The following video will help explain the process in operating these new machines. All their machines are manufactured in-house via a rigorous manufacturing process where all machines are thoroughly inspected throughout each production stage. This wax printing technology comes directly from inkjet printers. The difference between the two are instead of using ink, they use hot wax. The paper has been replaced with a plate that lowers itself after each layer is printed. This creates a 3D model. The wax used is unique and is fully castable. It comes in a granule form. You simply remove these caps and pour it in. The machine uses two different types of wax. It's stored in two separate heated tanks, and during the build it's pumped through heated lines into two jets that spray the material onto the build as needed throughout the process. The blue material is the build wax. It becomes the actual finished model at the end of the job. The red wax is used to support all undercuts and overhangs while the model is being produced. To set these new generation machines up is a lot easier than the previous model. Every 48 hours the machine needs to be purged and primed. First of all, you bleed all the air out of the jet and then replace the air with the correct amount as the air dissipates over 48 hours. From here on in, the machine is fully automated, allowing you to get on with something else. Its automated process starts by checking the jets to make sure they're printing well. The machine then prints a series of lines on paper tape. It's then pulled through a sensor which analyses the amount of wax the machine is using. If the machine is running too rich or too lean, it will adjust itself accordingly. Now we have to create a file that the machine understands by laying all our CAD files as flat as possible. Then we import this file into the program that comes with the machine called ModelWorks. The file is then imported into ModelWorks and positioned onto a fictitious build plate. The machine prints in layers, so we have to slice this file up into layers that suit the part. These slice thicknesses can be as fine as 0.0127 of a millimetre and give a very fine smooth surface finish. When ModelWorks finishes slicing the file for the machine, it also shows a printable estimate of how long the job will take. This is the actual file that is transferred to the machine and shows how the printer sees each layer. And like an inkjet printer, it prints one layer at a time and then drops the plate after each layer. The darker colour is the actual part and the red is the support material. Once this file is downloaded into the machine, you just press start, the machine calibrates itself and away it goes. This video shows the machine applying the support wax. It prints layer by layer and this thickness was determined in ModelWorks earlier. At the end of each layer the machine has a cutter which trims back the surface of this layer for the next layer to print on. This process is repeated until the part or parts are finished. Because the machine runs unattended, if the jet has a hiccup during the build, the machine will go through a cleaning cycle to make sure the part is not compromised. When the parts are complete, you simply remove it from the machine and place it onto a hot plate. The heat generated passes through the build plate and softens the underside of the red wax. The waxes are then removed from the build plate, and as you can see, they're totally coated in a support wax which is then removed in a hot bath. This bath is heated to 55 degrees and contains a solution that easily melts the support wax and leaves us the desired part in the bath. To wrap this up, Solidscape machines run unattended to create accurate and fully castable parts. So with this system, you're only limited by your imagination.